typically you will end up pre-weakening the structure, and that is where you really have to think about what you're doing and understand how the structure behaves, how it's going to behave once it's pre-weakened, how it's going to behave under wind loads once it's pre-weakened, proving it's stable before the final cuts are made. There's lots of things to think about. One of the key points is the workmanship, so how good the burners are. They have to be good burners, and they have to be able to understand the drawings, which is why it's important you make nice clear drawings for them. Yeah, they have to be experienced in the work. Setting it out, not something to be trifled with either. You've got to make sure that the drawings are interpreted correctly and it's set out properly, that someone is checking that it's been done properly and matches what the design intent was. You've got to think about the form of cut that you're trying to make on the steel section. Can it actually be done, making sure that the burners can achieve what you think or what your design requires. It's not the place for just winging it. You should be proving that the structure is stable, and that a big part of that is thinking about the age of the structure and the potential material properties. You might even go so far as to actually have the steel tested to understand what grade of steel it is, how strong it is in reality and compared to what the code might say. So in some cases, the steel might be significantly stronger. And then if your tabs are too big, you can make it very, very difficult to initiate the collapse of the structure. Similarly, if it's a lot weaker than you think, so it's a mild steel rather than a higher grade structural steel, you can make the tabs too weak. There's all sorts of things to think about. You need to have suitably experienced engineers doing this sort of work. So the drawings need to be clear and concise. It's not the place to try and be too clever. You've got to keep it simple so people can understand the mechanisms and where you've got to cut, how you've got to cut, when you've got to cut. And it's a good idea to do a sensitivity analysis because often you're estimating structural weights, the weights of components within the building. So you want to be looking at a lower bound, an upper bound, and what you think the realistic load is, because additional dead load can make the structure more stable. Therefore, you need higher pull forces. Similarly, if the weight's lower, it might not be stable under wind load. So there's lots of things to consider with that. That's an example of a chimney being pushed over. Nice, simple. Again, you've got to think about where you cut, how the chimney's going to behave as it's pushed over. Appears simple on the surface, but actually requires some thought to achieve safely. Blowdowns this is probably the most impressive things to go and see in terms of demolition. This is Eggborough Power Station, and the 8 cooling towers were demolished in 2 different phases, October 21 and August 21, as you can see there. And the idea was to collapse them in towards each other. So the engineering on this is relatively simple. You're really looking to make sure that once the pre-weakening is undertaken, that they will remain stable, and confirm that you can do test blasts on components to confirm how much explosives required. So it's not that tricky. It's quite interesting. We hope standing on site, seeing them come down is quite an awesome feeling. So you blow the legs and blow a slit in the side, and the way they fold up, it still amazes me every time you watch it.